Hello and welcome to our panel discussion on sustainability in the lab at the Wiley Analytical Science Conference. My name is Christina Pogel, Editor-in-Chief of Wiley Analytical Science, and I will be your host today. And I'm pleased to introduce our panelists who are key expert in the field. Here with me are Egbert Dietrich, the Managing Director at Egnaton, Kerstin Hermuth-Kleinschmidt, Consultant at NIUB Sustainability Consulting, Rachel Ralphs, Chief Sustainability Officer at My Green Lab, Thorsten Teutenberg, the Head of Department of Research Analytics and Miniaturization at the Institute of Energy and Environmental Technology in Duisburg, Germany, and Mauricio Urbina, the Professor of the Department of Zoology and Associate Research Fellow at the Institute Milenio de Oceanografía of the University of Concepción in Chile. So, everyone who is working or has been working in the lab should be aware that research is extremely resource intensive. Mauricio, in 2014, you published an article on the level of plastic waste that is produced in laboratories worldwide, with the shocking result of more than 5 million tons per year. Can you tell us what happened since then, since your paper got published, from your perspective?
Okay, well, first, I thank for the invitation to be here. I think it's very relevant to be discussing or talking about this. And to be totally honest, I'm not entirely sure what happened since then. Things are very different from country to country, from lab to lab. And also, at that time, we basically tried to get the first numbers, basically. Those were like back of the envelope numbers, and stats or really accurate numbers are really hard to find, are simply just not there. So it's really hard to evaluate whether or not we have improved a little bit or not. My feeling is that we are more or less the same, but we are talking about this. We are going to a stage, to a position where we are. I really hope we are kind of ready to start making some changes, trying to get those numbers, and based on those numbers, evaluate the real extent of the problem and what we could do to be part of the solution for the future.
Okay. Great. Yeah, thanks for that. As you mentioned, it is a difficult question, especially as countries handle the problem differently. I'm really happy that we have panelists from 3 countries here with us to discuss it. So, Rachel, my question to you, as the Chief Sustainability Officer at My Green Lab, is your goal is to create a culture of sustainability through science. What, from your perspective, are the biggest challenges your organization is facing in achieving this?
Yeah, I don't know that I want to throw it out as a challenge that we have, but I think that one of the very first steps in addressing sustainability in the laboratory is awareness, right? I think, as Professor Urbina just mentioned, we are now talking about plastics in the lab. And I think I can say that his paper has been cited by so many people within the Green Labs community as at least some reference point, some starting point for beginning to understand how much plastic and things like that we're using in the lab. So I think that the first thing that we have to do as scientists and as people who work with laboratories is to become aware of what the environmental impacts are and what we as individuals can do to influence them. What the impact can we have through the behaviors that we have, the activities that we do in the lab, and how can we be forces for positive change?
When you say we, Rachel, who are you mainly addressing? Is it really the researcher who is in the lab? Is it maybe also the manufacturer of consumables, of whatever? I mean, sustainability is a broad topic. So who are the main people we have to talk to when it comes to sustainability?
Yeah, it's a great question. So much of the work that we do focuses on engaging individual scientists within the laboratory, and they are definitely an important component of this. their behavior and the way that they use materials and the way that they do things in the laboratory in some way influences what the manufacturers are creating, right? They are meeting a demand and a need that is present within the laboratory. So we have to engage the people who are at the bench. But it is also very important for us to engage the suppliers and those people who are making the equipment and the supplies in helping them to realize those areas where they could really innovate and provide great change that will support sustainability across a variety of laboratories. So I think it's important really that we look at the industry holistically and really all of the players that are part of that. And I think in that engagement, even within those organizations, we find that we get people involved who aren't directly in the laboratory, but who support laboratories, right? So there's a great deal of overlap between laboratory sustainability and safety, for example, or regulation. And these people become heavily involved in it as well.
Okay, great. Yeah, that makes sense. So you said that individuals need to be addressed and the industry, but there are also some universities who want to become completely plastic free within the next few years. This is a question to all of you. Do you think this is a realistic goal, especially in these fields of life sciences and medical research where safety plays a big role? It is a difficult question. Yeah, Thorsten, please go ahead.
So I'm not sure if it's really possible to be totally plastic free. So there are some methods, some specifications where we cannot use just glassware or stainless steel or something like that. But as was already mentioned, the most important point is, I think, the awareness. What might be very interesting to discuss is what impact will have 3D printing or additive manufacturing. So we are also experimenting with this. So we want to start to print with a very low cost printer, microfluidic chips and some kind of consumables. So just fittings, ferrules and stuff like that. And the impact this could have on the environment is, so sometimes the shipping comes from USA or wherever, and just few consumables. So first of all, we have to wait some weeks until they arrive, and then there is huge packaging and so on. And here the concept of in the lab would be very, very interesting, but of course it would also generate more plastic. And because it's a technology that is readily available, and there could be advantages, there could be disadvantages, other great problems, but I think it will not entirely be possible to completely eliminate all plastics from the lab. That's for sure, in my opinion.
Yeah. I think you also brought up another important point. Of course, shipping is a big topic too, and this shows how broad this topic of sustainability is. Even if you use reusable materials in the lab, where do they come from? And this is also a question that needs to be asked. But Kerstin, you wanted to comment on that question too.
Yes, I think it's first of all, I think it's a good idea to think about 3D printing. I'm curious how it will work. And the other thing is, I don't think that you can be 100% plastic free, but I think, as Rachel said, it really puts the awareness there, and that you're really looking into your routines and what you're doing in the lab daily. Because I think a lot of these plastic things, these are convenient, they save you time, but on the other hand, you're using such a lot of things which in former times haven't been out of plastic. So I don't know if you're thinking of these little inoculation loops for bacteria. They've been made of metal when I was in the lab, and now they're made of single-use sterile compact things, and you just need them once. And I think this is this is something where you can say this goal of plastic free, you won't get it, but it raises a great awareness.
Yeah, Mauricio.
Yeah, I totally agree with my colleagues here. I mean, plastics is a great material. The problem is that we use it for everything. For each single thing we have to do, each single action, each single protocol, it's just plastics is everywhere. And I think the key is basically approaching this thing holistically, as Rachel says, and trying to maybe reduce plastics where we can, and carry on relying on them, for example, for a qPCR or for a real-time PCR, right? I mean, there's no point in using something else, and that's nothing wrong with it. But at least we should make an effort and evaluate from which actions or protocols, in which areas of the science we can actually go away from plastics and start using, glass, for example, which is a great material. I know it's going to be different or hard on cost, but one of the things we say in the Nature paper is like, why science, which is basically a luxury, generating knowledge, and usually as mankind we use this knowledge to improve our life and the life of everyone, including the planet, right? Why we should be sacrificing something? I mean, our planet, or putting ourselves in a position where we are so heavily involved in being part of the problem by doing our science. Why we can just accept that we're not earning money here, we're not making profit? Why we don't just take seriously and just go back to, even if it is more expensive for us now, but it's something that funders should be aware of it. And if science became more expensive, well, I mean, that's it. It's fine. It's fine with me, at least.
Very nicely said. Thank you. Rachel.
I think everyone has said some really wonderful things about this, and I think I agree with everyone also that it'll be very difficult to completely eliminate plastic from the laboratory, if not unrealistic. And I think perhaps unrealistic in a short time frame, because I think that there are things that we as individuals in the lab can do, protocols that we can look at, or particular products that we use, and we can think about alternatives. But there also has to be innovation, and Thorsten touched upon this with 3D printing and some of these other technologies that are coming. Innovation is going to be something that is needed in order to make really big transformational change in this, right? I think one of the most common waste streams within a laboratory are things around liquid handling, pipette tips, right? I don't know that anyone can imagine using anything other than a plastic pipette tip. So if we're going to get rid of pipette tips, I don't think it's going to be a switch to glass or something like that. It's going to be a new technology, a new innovation that changes how we manipulate liquids in the laboratory environment. So I think those are kind of two components that are needed for this. It's a little bit of behavior change, but a whole lot of innovation.
Yes, please.
Well, I like to point out something, I think, which makes the thing a little bit better. So from my point of view, plastic, or using plastic, is not plastic. So when we talk about plastic in labs, there is in the background a system of reuse. The societies are scared about plastics, for example, in the oceans, in the sea. But the plastic which is used in the lab usually never comes to an ocean. Otherwise, we do something wrong. So, I mean, even if we produce plastic from crude oil, for example, nothing happens with respect to the CO2 balance so far. Only if the plastic is burned somewhere in an industrial society, an industrial fabrication or somewhere, something happens. But we have the options in a lab to organize this. And therefore, from my point of view, plastic is not that bad in the lab, like maybe plastic bags somewhere in the third countries.
Yeah, that's another important point. When you say that most plastic from the lab, I assume you mean that it gets recycled, but there are some safety concerns, especially with contaminated plastic. Do you know, what's the solution for that? Or what happens to that contaminated plastic?
Clean it up.
Yeah. No, and this is exactly the point. I don't know the answer either. I guess this is difficult to treat, and I guess apart from burning and energy reconversion, there's nothing really to do about that. But this is an important topic too. The reuse of the plastic that is consumed in the lab.
Mm-hmm.
Okay, I don't know who of you was first. I think Mauricio.
I think it was Kerstin.
Yeah.
Sorry, Kerstin.
It doesn't matter.
Please go ahead.
No, yeah, but just what I would say, yes, the contamination of the plastic is a big problem, and it's very difficult to reuse or to recycle it. Perhaps I know that some companies are working on the topic of chemical recycling, just trying to make a sort of oil out of it again. And perhaps this is something in the future which could be a possibility, an option.
Okay, I think now Mauricio and then Rachel.
Yeah, as Egbert was saying, I mean, the plastics in the lab, the plastic we use actually to do science, it's a problem. I know, we all know that. But it's only part of the plastic we use in the lab. I mean, when we buy, for example, like plates or Falcon tubes, the packaging where they came is sometimes like, almost equally heavy in terms of grams that the product that we're buying. So the plastic we use is one thing, but also the packaging involved, in the plastic we are buying. So I know it's something that we need to be aware of. And maybe if we're not able to reduce plastics in our, real science, we may be approach like reducing plastics on the packaging for the plastic we use in science.
I think there is great opportunity for us to address the packaging piece. And, I think one of the advantages that laboratory plastics have is that it is typically very high quality plastic, right? These are usually, very high purity films or materials. They don't have a tremendous number of additives and things that do contribute to them not having as long of a lifespan in the recycling system. There are, of course, those challenges around, contamination that are real concerns. And there are opportunities, I think, even today for us to be looking at how we're using those plastics and where we're using them in the lab, and perhaps segregate out different work streams such that we can isolate those that maybe have non-hazardous plastics, where we could recycle some of those and then keep the other ones separate. There are technologies out there that are being developed in order to address these kinds of things, chemical recycling being one. There's a company here in the US that is able to actually sterilize and recycle even biohazardous plastics. So I think that there is also innovation that is happening here. But again, I think it will take some even bigger innovation for us to really close the loop on these materials and even think about reusing recycled plastics in creating a laboratory product again.
Yeah, so we discussed now a lot about plastic waste, but the reduction of plastic is only one important aspect to make work in the lab more sustainable. From your experience, Kerstin, as a sustainability consultant, which other measures would you recommend in order to achieve a green lab?
I think as Rachel already said, you have to be aware. You have to be aware that you're using a lot of resources in a lab. So imagine you have a lab building and you're using 3 to 5 times more energy and water in the lab than in a normal building. You're also using a lot of chemicals. You're having a lot of waste. So I think the first thing is to be aware of your impact. And then the second thing is really to look into your routines and what you're doing. So, for example, think of freezers, think of autoclaves, think of fume hoods. So very simply shut the sash of your fume hood and you can save energy. Or just when you're autoclaving, you will always use the same amount of water and energy, whether it's fully loaded or not fully loaded. So just only let it only autoclave when it's fully loaded. Look on the temperature. You can have a temperature at 34 degrees or 121 degrees. So just have a look what suits your purpose, what do you need. And then you have a lot of instruments in the lab, and they also produce heat load. So I think they're also impacting the air conditioning. And just have a look on the use. So are they in standby, your instruments? Do you really need them all the time? There was a study in England where they had a routine experiment and they had the instruments always on. And then somebody asked, well, how long is your experiment running? Oh, we need it for 15 hours. So they just had to shut it off and they could save 30% of energy. Or another one who said, oh, we have an incubator here in the lab, but actually at the moment we are not doing cell culture. We don't need it. We just can put it off. So I think these are the things that you can do. And the other thing is water in the lab. So be aware that we don't use tap water in the lab, but we're using purified water. And when you're doing it by reverse osmosis, about 50 to 80% of the water is going to the drain. So if you're having 1 liter of RO water, then you use 2 to 5 liters of water. So also again, just use the appropriate quality, use that what you need. Another thing is reuse whatever you can. Also share your instruments, another thing that you can do. Look on the procurement. So we have different labels in the meantime for the lab instruments. So I think Rachel can tell something about the ACT label. We have this Egnaton Cert label, which is for big instruments. We have certified already cage washers. We will have further instruments in the future. So I think there are a lot of possibilities. Yeah.
Yeah, thanks. This gives a great overview on what can be done, what everyone can do. Rachel, you would like to comment on that?
Yeah, absolutely. Kerstin gave really some fantastic examples of the things that we can be focusing on in the laboratories. And, I think really waste is something that is very tangible for people. And so they want to focus on that first. And I have found that is one of the harder ones to address, right? Because we are accustomed to these materials. And like I said, I think it's a little bit of behavior change and a whole lot of innovation to have big strides when it comes to waste in the labs. But energy and water are huge areas where we have a lot of potential to reduce. And around water, when it comes to things like autoclaves or water intensive processes like single pass cooling, that's a practice that we see in a lot of university research labs, that there are really nice alternatives to that sort of thing out there, so you really don't have to do that. Water vacuum aspirators are another thing that is basically like single pass cooling that we see in use a lot, that use tremendous amount of water. So great opportunities to really do things differently around that. And then when it comes to energy, yes, fume hoods absolutely are something to focus on. And one of the other areas that we really focus on is cold storage. And I think this is feeling more and more relevant these days as we hear about how cold vaccines are going to have to be stored, and the number of ULT freezers that are being purchased globally. There's a tremendous footprint associated with cold storage in a laboratory, both from the actual energy that it consumes, but also because of the heat that it discharges and the load that puts on the heating and cooling system within a laboratory. And there are steps that we can really take to make sure that we are using that resource optimally. So at My Green Lab, we have what we call the International Freezer Challenge, which is an annual competition that we host that encourages people to adopt best practices with cold storage. So really looking at how they can maintain cold storage to keep it running optimally, how they can really maintain the samples that they're storing, and use those resources to their fullest potential, and make sure that they're not kind of storing things that they don't really need anymore and saying, oh, we're out of space, we have to buy a new freezer, or, looking at opportunities that they can share with a colleague if they aren't using the full capacity for a freezer and things like that. So I think the freezer challenge is a great way for people to kind of kickstart thinking about energy usage in the lab, and really focusing on one piece of equipment that is very energy intensive. As an example, one of those -80 ultra low temperature freezers, especially older ones, can use somewhere around 20 to 30 kilowatt hours per day, which in comparison to a US house, that's about as much as a US house. So imagine for some European countries, maybe that's 2 houses. But there are Energy Star rated ones, which is an energy ranking system here in the United States, that are much lower energy consumption, more closer to 10 to 12 kilowatt hours per day. So making sure that you're always looking for those sustainability labels, and purchasing the most energy efficient equipment is an important thing to do as well.
Great, thank you, Rachel, for this addition. I think we now had many points which individuals can work on, how they can change their behavior. Some things require some more investment, as you said, more energy sufficient instruments. Egbert, this is now more a question to you. What is possible in the field of laboratory construction and infrastructure, and what developments have there been?
Well, laboratory buildings are, to a certain extent, not among the most common buildings in quantitative terms, for example, but they are of a great technical relevance and primarily serve purposes of the highest importance for the entire society. So the workplace for laboratory users is demanding and complex and critical to the output of the researchers. Society expects researchers, to be honest, to find sustainable solutions, processes, materials that will have less impact on the environment in the future. So therefore, the research buildings as such must also be sustainable. In other words, they require a sustainable planning, a sustainable construction, and a sustainable operation. That only works with technical solutions, of course. And these in turn are different for each building. Research, and with its demand on research buildings, is constantly reinventing itself. In this respect, the design criteria of research buildings have to be constantly adapted to the research tasks. And this is the big challenge in laboratory planning. Laboratory planning, for example, has to follow the trend that laboratory research is becoming more and more interdisciplinary and, of course, also heterogeneous. Laboratories are used today by teams, big teams, whose requirements range from wet chemistry to life science. That influences the technical requirements. It also makes intrinsic laboratory safety much more difficult to establish. And above all, the typical requirement of an interdisciplinary team must be met to be able to communicate easily and safe. So this is a challenge for the architect and for the planning team. One of the most important changes in lab planning for sure is, and maybe this is surprising for you, is that the planning itself must be sustainable.
Okay, what do you mean by that? Can you tell us what exactly that means?
Imagine you're facing an operation, and the operation theater is dirty. So do you expect that the doctor is doing a good job? So in other words, the workplace to develop sustainable products and processes must also be sustainable. You know, it has a very high impact to the work itself, how the environment of the lab looks like. So that is very important, and the entire process must be sustainable. You know, we cannot forget sustainability when we starting with planning, for example. So there must be some criteria like charrette design, like team building, like communication with all the team members and different trades, for example. So if you don't do that, the result at the end of the day, the laboratory buildings, the research building, cannot be sustainable to the highest extent. We have made this experience within Egnaton in our work group of the architects. We are right now working on a virtual project, which is a virtual building, and we want to show that all these results we have developed in the past years, that they work, and it only can be implemented. Sustainable solutions can only be implemented also in a sustainable planning process. So when you talk about sustainability, you cannot leave away sustainability when you leave your office. You must act as an individual human being at home, in your own home, also sustainable. Otherwise, it won't work. It's an overwhelming bridge about our action, which we take as human beings, to be sustainable everywhere.
Absolutely. And I think there are slight hopes that the attitude changes slowly. So people become more and more aware of their actions with regards to sustainability. And Kerstin and also Rachel, when you described what every researcher can do in their everyday work to be more sustainable, I was thinking that these advices we also learn maybe from our parents or at school, how to use less energy, less water at home. And I think there are so many concepts that we know about, and we would just have to transfer it to our work in the lab. Absolutely.
Yeah, I very much agree with that. And I think that is part of how we see our mission actually impacting people's lives even beyond the laboratory, right? We're looking to create a culture of sustainability through science. And I think that culture of sustainability we truly have found when people start thinking about sustainability in their work, right? And we have programs and tools really designed to almost force them into thinking about these things and really giving them very discrete actions and things that they can do within the lab. Turning off the lights, closing their fume hood sash, turning off the tap, reporting a leak, you know, et cetera. That they take that kind of knowledge now in action, and they do bring that home. And we have had people come back and say, you know, I'm now turning off the lights at home, or I now clean the coils on my refrigerator at home because I learned that that was an important thing to do in the lab. So I think that it does translate between the two, and it is needed to translate. But I think that is a big piece of what that education and awareness does, right? Is that once we become literate in sustainability, once we understand what needs to be done, we can see what our role is in that and the actions that we can take. And we can take those whether we're at home, whether we're somewhere else, whether we're at work. And it becomes just part of how we act.
Absolutely. So we already said that, yeah, the personal behavior is the one thing. The other thing, and the big hope, is that we get more and more advanced techniques. So Thorsten, you already mentioned the additive manufacturing for yeah, plastic consumables that would at least reduce the shipping of instruments or of consumables. What else, for example, how can miniaturization and digitization in the lab contribute to achieve this goal of sustainability?
I think it can have a really big impact. So I'm not sure, but I think in our lab we use since more than 10 years micro LC. And I think liquid chromatography is one of the most prominent technologies in an analytical lab. And much of the methods were developed in the late 70s or 80s by the pharmaceutical industries, and still they use these old methods. And I've really in the last years talked to many people from that industry and try to convince them and say, okay, if you have to revalidate the method, or if you have to develop new methods, why not change, and why not use these very advanced micro or even nano LC systems? So they're quite robust. So it's not as in the early beginning of this millennium where you had not the appropriate equipment. So now we have really robust equipment, and it's fascinating to see that you can do an analysis even 10 times faster. Of course, you can really optimize the cycle time. That is a little bit tricky to improve the linear flow rate, and then you end up with just a few nanoliters of very toxic solvents we still need for chromatography. So we have to we cannot do this purely by water. So I've finished my PhD by high temperature liquid chromatography using only water, but this is a very special technique. But applying miniaturization in this concept would be very easy. And especially in this respect, my hope would be that especially academic institutions would adopt this concept, because if you're working as a student with this kind of technologies, then you will very easily transfer these methods in the institutions of the industry you will work on later. So this is one great aspect, and of course, if I miniaturize the systems, I need less space, less lab space, and this in itself is a great opportunity to save resources. And if I can put, let's say, 4 times as much equipment in the same lab, and improve even the throughput per system. So this is a very high and big advantage, I think. So this is one thing which can be done ad hoc. So digitalization is a little bit tricky, of course. So we are also now working to establish a lab which, where all processes can be automated and also fully digitalized. So to remove the paper issue, we all know. This is quite hard work. So, but there are different vendors of instruments, so different standards. So we have to see if we find an agreement in the next years. Is this ZILA standard or OPCUA? Is this will this be the standards where everyone can agree on? And then it would be much easier to connect all instruments and then to have a fully digital audit trail. And then I would not have to print everything out, because it's I think is also something which is a problem around the world. So we have ever more routine tasks to fulfill, documentation, validation, and so on, and ever more paper is generated in the lab. So I think these two issues can be very helpful. And another aspect we also use since many years, there is simulation software. So if I do method development, I could rely on software like DryLab or ComSort. It's available since more than 20 years, and I don't need to make 100 experiments. So I can do 2 or 4 experiments and make a simulation on the computer, and then try to find the best method. So it really also saves resources. So there's, I think, a great toolbox which we can use to become more energy efficient. And I would also agree on the statements other participants mentioned. Everyone has to be aware. So we have to apply the same principles at home as it works. So turn off the computer. So if I go to the laboratories, they've seen the screens are not turned off after people have left. And I think these are the tiny little things what we can all do, and they will have a big impact if everyone is doing this.
Absolutely. Yeah, I think the technical advances, the advances in the buildings, the laboratory buildings, make really optimistic, and the great work by all of you, which raises the awareness for this problem, really makes a big impact. But of course, we should ask ourselves, will this be enough? Will a change in the attitude will come fast enough? And what if not? And yeah, one difficult question is, do you think something that we could see in many countries that, for example, plastic bags and wrappings have been regulated or even forbidden? Do you think something similar like this, political measures, could help when it comes to the use of plastic or the use of resources in general in the lab? Rachel.
I'll be the first to address this, I suppose. You know, I think that regulation can play a role in this. And when we look at, for example, the EU REACH regulations, those really were designed to to promote innovation through regulation, right? So they're kind of taking particular materials off of the market and almost forcing them to find alternatives and to innovate and find new materials. And you know, in my experience working with life science companies, it does actually kind of have that effect. So I think that there is a role for those kinds of regulations and in helping to really push the industry away from the most harmful substances and those that we really do need to be steering clear from. I think we do have to balance that against kind of what's possible right now, right, and what can be changed. But I think that's where, you know, governments and intergovernment agencies really have great power to review these things and I think make good global decisions around that. So I do think it's an important aspect.
Yes, Mauricio, please.
Yeah, I totally agree with Rachel. I think regulations are important. It's not the most important or the only thing, you know, or it's not the main driver we should be waiting for actually, you know, have some action on the problem. But it's good to see that everything's moving to, you know, to get to the same goal basically. So make us more sustainable. So and you know, we love diversity and we're all different in terms of personalities. And some areas, some sectors of the society will, you know, will react quicker if there is regulations, while others don't need regulations. They just do it because they want it, right? So I think it's good. It's for sure a positive thing. It's not the only thing we need to rely on. We can do changes without regulations, but it's good to see that everyone's moving to, you know, in the same direction.
Yeah, I think as soon as we start talking about regulations, there are concerns about politics influencing research in some way. But I think this ban of plastic bags in Germany, for example, was a good example as well. It was really controversial because people said, plastic bags are really only a small amount of the total plastic waste that is produced. On the other hand, at least from my point of view, it made people become more aware of their overall plastic use. This I think is one aspect. But Egbert, you would like to comment on that too?
With respect to what I've said before, from my point of view, of course, sometimes regulations help. But on the other side, you know, our options shrink and the creativity shrinks. So for me, it would really make sense if we get more regulations with the respect of the reuse of the plastic. So not of forbidding the plastic itself, but we have to take care what happens with that stuff.
Who should be responsible for that? Because I think this is a really difficult question. The use could be the individual, could be the supplier, but who in the end is in charge of the recycling of the plastic? I think, yeah, this is definitely one question where, yeah, that needs to be answered maybe by governments, maybe by institutes, but definitely something, yeah, to think about. Well, another big aspect which is really key for research we haven't talked about, but yeah, this format here, this panel discussion as a video is a good example, because Now, with the COVID-19 pandemic, travel is almost reduced to zero, so there are no conferences. The exchange doesn't really happen in person, so everyone goes virtual now. And like I said, research is living, or it's key for research to be able to connect to fellow researchers and to exchange your work, your thoughts. Do you think this pandemic will now boost online formats like virtual conferences, or will the in-person events come back at this level that we had before? What do you think? Kerstin, please.
Yeah, I would say I do hope that they become part of normal, of the new normal, because on the one hand, you really you can check or you can really reduce your carbon footprint. I've had a study some weeks ago where they really they had a look on a conference of the European Astronomical Society in 2019. And there were about 1,200 participants, and they had a carbon footprint of, I have the number here, 1,855 tons of CO2. And they made the same meeting this year with more participants, so 1,700, and they only had 582 kilograms of CO2. So this is a factor of 3,000, and I think this is really something we should be aware of, because the researchers, it's true, they really have to exchange, everybody has to exchange, but going to a conference, I don't know, every year, flying, or even more flying by plane, this is too much. And I think it would be good to have less in-person events, or to have them as let's say, local meetings in a place where you can meet, and then you can connect with each other via Zoom, or like here in a digital meeting. And the third thing I would say is that with virtual formats, everybody has the chance to participate. So it's also about equality, so that everybody can take part of it. So, well, I hope and I think that we will have more digital formats as everybody gets used to it.
Yeah. I think Egbert, you wanted to say something about that too?
Well, yes, for sure. We will have much more virtual meetings, and they will not stop. And what Kerstin said is absolutely all right. But there are some other things also we have to take under consideration with respect to the pandemic. For example, we have been working on strategies how to design a lab building for safe of pandemic. So this is also an issue which drives us, because laboratories have to work. We cannot stop work in laboratories, in certain laboratories, of course. Yeah. And of course, I'm also strongly believe that lab work is essential and hardly can be done from at home in exceptional but increasing cases only. Of course, the requirement to control my lab process can be gained from any location in case the digital systems are established.
Absolutely. Okay, Thorsten.
Yeah, I think what Kerstin said, I can fully agree. So, of course, a personal meeting is always unique. So, I mean, it's great to see you here all on the screens, but it's not the same as meeting you in person. But on the other hand, I also think, especially during the last years, there are too many conferences. So for me, the HPLC is always a conference which is very important. Every 2 years in Europe, then we have, I think, in the US, then Asia, then Australia. So in some scientists are there on the same meeting, holding the same lecture on 3 different continents in 1 year. So this is really not what a scientist which is also embracing sustainability should do. So I think the hybrid format will be the next standard, because we are doing some regional meetings, one-day meetings, and the important thing is how to distribute the information. And I have many colleagues working in Munich or in Berlin, and they say, okay, it's very nice what you make, but just for one day traveling, stay overnight or taking the plane or whatever, that's not very useful. So, but
sustainable.
It's not very sustainable. So, in the end, when we learn to manage with these digital tools, so when we can establish hybrid formats where everyone can participate and also discuss, but then I have also the core members, which are then meeting in person. That's a really great issue. So in this respect, I think this is one positive aspect we can learn from this corona pandemic. And one thing I would like to comment on Egbert's issue, we're trying to work that the lab, not fully, but let's say to 80%, can also be operated from the home office. Because now we have automated systems, so you can prepare your standards fully automated. There is one group, this is experimenting with mobile robots. So we all know them from your households, of course, and this can do very simple transportation issues. So just bringing the sample from the liquid handler to the analysis system, and in principle, I can control all these systems also from home. And then I would have to, one or two technicians in the lab who can do emergency things if there's a system failure, of course, or things which cannot be automated. And this, and especially the case, and what we have seen where we need to operate the labs, it's very, very crucial. We see also here at our institution, and if there's one case we have to, 3 or 4 people have to go in quarantine, then we have a really big problem. And I think this is very important to work in the future. So, yeah.
This is a fascinating topic, and I'm surprised to hear how advanced all this is. And I think this would be a perfect topic for a whole other panel discussion. I probably will reach out to you again. But Rachel, you would like to say something about it too.
Yeah, I think that conferences are going to return to some extent. I think people are going to want to come and meet in person, but I do think that it will be more of a hybrid approach where there will be the opportunity for more people to, to call in or to participate virtually through a poster session or, a panel discussion like this, or even a talk. And I agree with Kerstin that does help with the equality piece of it to a great extent. And I think that's really, really terrific. I think that the part that's really going to stick is how people view the needed travel when it comes to collaborations or even within their own organization. So we work with a lot of global companies, and obviously they have not been traveling between offices as much. And many of the people that I talk to say that this is going to become the new normal, that we're not going to take these trips, just to go meet with a few leaders anymore, that we're going to find ways to do that virtually. So I think that part will stay the same.
I think already this would be a big step forwards. Yeah, thank you. Okay, after this amazing discussion, and before it's getting entirely dark here in Germany, my light is really energy efficient, as you can see. It's getting really dark. I would like to close the panel discussion with a quick question round to all of you. Can you please tell us, what do you think, how working in the lab will look in 5 years? Mauricio, would you start, please?
Thank you. Well, it's really hard to tell. I think we are obviously on the right track. We're moving, we're being conscious of what are the effects of our actions, and we're at least trying to do something to move forward and to solve the problem. As we just discussed regarding these, like global conferences, I mean, we love enjoying beers or coffee with colleagues and talking about different nonsense things, over a graph or, over a data or something like that. And honestly, I'm really missing that part of science, and we all are. But we have to accept that we are being more sustainable and more efficient just by using technology. So I hope our attitude and several of our actions are going to change at least a little bit in the next 10 years. I'm really hoping that. To be honest, I'm not able to actually say or dare to quote an example of how it's going to look like, but I think we're in the right direction. So I think we're going to do much better than now for sure.
Okay, thank you. Egbert, what do you think?
Well, I just have some buzzwords. It's digitization, it's communication crossing borders, and sharing instruments and devices within interdisciplinary teams. And my personal wish is to get the users better known with the building. So they have to know the possibilities with what the building offers to work sustainably. So how does a fume cupboard work, the ventilation work, or what does my device management look like? This is something we have to address to the users as well as the users have to get more influence in the planning process.
Okay, great. Kerstin, what do you think?
Yeah, I think I can just say somehow the same. So I think as Egbert and as Mauricio, I think we will have more digitalization in the lab because it could help, as Thorsten Teutenberg said, when you can one day be at home and make your lab from home. But also we already have solutions like inventory management systems and these things. And I think we just have to use them to track our things, to make them, to know where my things are, my samples, my chemicals, and so on. I also think that, as we discussed, we will have perhaps less travel, but still the digitalized formats. I hope we will have more miniaturized systems. And what I would say is what Mauricio already said. I think we will have more awareness by the users what their impact is, because I think it was really the last year or the last 2 years when really the green lab idea was coming, I don't know, to the labs. And I think this is really something which will go on.
Okay, great. Rachel.
Yeah, I think that this is a really exciting time for green labs and for lab sustainability. This is a movement that is relatively young. I mean, it's only been around, maybe about 10 years, really. And it's at just kind of a fantastic acceleration point right now, where we are seeing so much interest in this and so many organizations really working to bring sustainability into their laboratory operations. And so I think that within 5 years, we're going to see a very large percentage of the scientific community engaged in sustainability and thinking about sustainability in their day-to-day work and having that become part of how they do their science. I also think that there is a big wave of change happening in education at this point as well, and that we are seeing a lot more organizations incorporate, for example, green chemistry into their undergraduate curriculum, such that these ideas of sustainability and really thinking about how do we start designing things to be more sustainable from the very beginning, I think is going to become part of the common chemical education and part of how we are training the next generation of scientists. And I think those kinds of things collectively, maybe not in 5 years, but certainly looking forward past that, is going to just push a wave of innovation through our industry. And I think we're going to see a lot of really positive changes because of this engagement.
Great, thank you. So Thorsten, you have the last word.
Well, I think so. We are living in exponential time, so I think we will see big differences. So on the one hand, I think in 5 years, there will certain labs which just operate as today. inefficient, not sustainable, well, not fully automated. And then we will see, I think, different kind of automation. So we're also using now systems which is just based on plug and play. So there are many very innovative startups, especially located in the Karlsruhe region. They've developed very interesting software and hardware where even a lab technician with no basic skills in IT or programming can put his or her automated system in place. And I think we will really see, especially in the units which have a lot of resources, that they will operate their lab fully automated, fully digitalized. And then there will also be labs, very small lab units, I think, which are operating as today. And this, I think, is very, very exciting to make some research in this respect. And I also personally hope that we can apply miniaturized LC systems also in the pharmaceutical industry within the next 5 years. Be my great wish.
Great. Okay, Mauricio, you would like to comment on what Thorsten said?
Yes, sorry, that's very quickly. One thing we should consider, I guess, is like science science around the world, it's going on different stages. So, and each stage has a different challenge. And I think we should be smart here and try to think, how do we move green, all along these different stages? So, for example, in terms of how money a country invests in science, for example, or even within the same country, some labs are very well funded. And maybe for them, it might not be a problem to throw away a whole bunch of plastics, not be efficient with power or water. But in other lab where they don't have much money or much funding, basically, they probably are very aware of the resources and they use them better. So I think it would be nice to maybe green labs make a, kind of design a way where we can move in parallel along different stages of science, just in terms of fundings or even advancements, or in different countries, like as a whole, as colleagues all together, as science together.
Great. I think these are the perfect closing words of this fascinating discussion. I'm really happy to have you all here. I think we discussed really severe problems, and I mean all environmental issues. They are just immense: climate change, microplastics in water, and all that. This can make or give a very pessimistic perspective. But what I really liked in this discussion, and what I find fascinating about each of you and all your work, is that you're working on solutions, and that you brought really optimistic message, and that there are technical solutions which are really advanced already, and we hope that they get even further within the next few years, but also that there are so many things each individual can do. Just to, you said it a lot, awareness is key to get some change in the behavior. Yeah, and with this, I would like to thank all of you. It was a big honor to have you here at this panel discussion during our virtual event. I hope, you enjoyed it as much as I did. And thanks everyone, of course, for watching. Have a good day.
Thank you so much.
Thank you.
Thank
Bye-bye.
you.
Thank you.
Bye.
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 Bye. Thanks.